Okay. Then we're going to get started. Same looking board as you've seen before, just a little bit of a different format in terms of how we'll play. Hopefully you have some review materials handy, whether that's your energy notes on gravitational potential and kinetic energy, or whether that's something like Flaming Peanut or Feel the Heat, so on and so forth. Is there a question? Okay, so our categories are vocab, kinetic energy, potential energy, energy conversion, and then heat. Why don't we start first with Gretchen? You get to pick any point value in category Gretchen.
Hello, good morning. Potential energy 500.
Okay, so I'm going to give you a little bit of time on this one. I want everybody to give it a try. It asks you, what is the mechanical energy of a juggler's pins? If you ever watched anybody juggling before, they juggle things that look like bowling pins. The pin is in motion and it's above the ground. So that's why it has mechanical energy. So it's got 65 joules of kinetic energy. It weighs 24 newtons and it's 1.2 meters above the ground. What I want to know is, what is its mechanical energy? In other words, a combination of the kinetic and the GPE that it has. So if you're playing along, we have to do something with these two values right here. When you have an answer, you can type it in the chat. I'll give you a little bit of time. I see some of you with paper and pencil handy. If more of you could get your videos up so I can see what you're up to. I don't mean for this to sound harsh, but if you're going to just sit back and be passive during this review, I would say go on to some other work. If you're going to be actively engaged in answering these questions, by all means, hang around, but I want you to be actively attempting. Question like this one, a few more hints for you if you are stuck in terms of getting going. We need to find the GPE of this pin. So we have to work with 24 and 1.2, and then we need to add it to the kinetic energy. Some answers coming in. Looking good. Okay, if more of you are still working, continue to do so. We're going to transition to the answer. Those of you that came up with 93.8 joules, that's a correct answer. Just know that this is kind of a two-part process. I gave you the kinetic energy. You needed to calculate the GPE that it had, the gravitational potential, and then add the two together. Mechanical energy is a combination of an object's kinetic energy and gravitational potential energy. Are there any questions on that? It's probably a little bit more involved in terms of the math than we'll see on tomorrow's test, but a good one to get started with. Noah, you can get
Vocabulary 500.
Let's see what we got with vocab. All right. The quantity of heat required to raise a unit of mass of homogeneous material 1 degree Kelvin or 1 degree Celsius in a specified way given constant pressure and volume. Now, if Noah has a clue, you can answer, Noah. We did talk about this. I'll give you a hint. This came up when we did the Feel the Heat lab with the hot spoon going into the cold water and then vice versa. If anybody else out there wants to chime in with an answer, we'll give Noah maybe 10 more seconds. Shrug. Anybody got a guess? We got one guess coming in from Preston. You're really close. This is the definition for the term specific heat. If you remember back to the Feel the Heat lab, we talked about conductors and insulators. So I'm not going to ask that you memorize a definition like this or even know it. But what this overly complicated definition says is that objects that are really difficult to change in terms of their temperature, those things are called insulators. And materials that are really easy to change in terms of their temperatures, those are called conductors. So we saw that with the metal spoon. It changed temperature dramatically. It had a really low specific heat. In that lab with the water, it took a lot of energy to change it. So we would say it has a high specific heat. It takes a lot of energy to change its temperature. Turns out the 500-point questions are pretty challenging so far. Let's hear from Aaron Rudolph.
Vocab 400.
All right. This goes way back to the beginning of distance learning. So what do we say is a resource that forms at a rate that is much slower than the rate at which we consume it? We'll give Aaron Rudolph a chance first, and then if he needs an assist, we'll hear from anybody else. We had kind of a debate on this. Aaron, you got a guess?
No.
All right. Brian, do you got a guess?
Yeah,
What is it?
non-renewable energy or resource or something.
Good. So we call these energy resources non-renewable. Aaron, could you give me an example of a resource that would be considered non-renewable?
Oil.
Yeah, exactly. We are currently using oil, gas, petroleum products at a rate that they cannot be renewed. So we would consider those to be a non-renewable energy resource. Let's hear from Leighton.
Heat 500.
All right. Why does a cloth, like you may experience this, especially in the summertime, the cloth part of a seatbelt does not feel as hot as the metal part after having sat in the sun. Why is that the case? Leighton, you want to chime in with some thoughts?
I was just going to say the cloth is more of an insulator while the metal is a better conductor.
Exactly. So now I'm curious to know if there's anybody out there that could unmute their mic and take it a step further and tell me what's true of the cloth and what's true of the metal in terms of their specific heat.
The cloth, you go, Brian.
The cloth has a higher specific heat while the metal has a lower specific heat.
Who was that just?
Preston?
Yes,
not
exactly.
Brian.
Exactly. So this is something that I'll post this review. This is a really great question though, in terms of prep for tomorrow's test. if you have the ability to take some notes at home right now, we really want to establish that relationship. Insulators like cloth have high specific heat. Conductors like metal have low specific heat. That's something we established with the Feel the Heat lab with the spoon in the water, but maybe in the meantime it's kind of faded away. I'm curious to know if anybody has questions on that relationship, but it's definitely one we'll see on tomorrow's test. So it's good to tell me cloth is an insulator, metal is a conductor. It's better to go another step further and reference specific heat, which I have in this answer here. Any questions or thoughts on that one? That was, Leighton, did you pick that one?
Yes.
Okay, Dylan, your turn to pick. I'm just kind of going down my list, but you guys keep.
Kinetic energy 500.
Okay. Similar question to before. What is the mechanical energy of a juggler's pin? But this time, I'm giving you the amount of gravitational potential energy it had. And I want you to find the kinetic energy component of the pin and then add those two together. Sister in the background.
Here, Audrey.
No, out.
Mics, guys and girls, please.
No, you can't have those. Those are
Thank you. I'm actually trying this along with you. If you have an answer, you can type it in the chat section. Mute your mics, please. Thank you. All right, we'll go another 10 seconds. If you got an answer, type it in the chat. Uh-huh. Okay. Yep. Our answer, looks like 10 of us coming in with an answer. Looking good. I rounded. But those of you putting in 196.04 joules, that is correct. Here's something I want you to take a look at real quick. Hopefully this is showing up clearly for you. On tomorrow's test, if I ask you to calculate the kinetic energy of anything, we have to recall 3A, 3B, 3C. This is the toughest math we do all year long, and it's proven to be tough, not in terms of getting an answer, but in terms of showing your steps. So again, I just want to repeat that when I show step 3A, I'm just plugging in the mass and the velocity information, showing that velocity gets squared, always over 2. In 3B, somebody besides Dylan or Brian, tell me what I've done.
Don't you square the the velocity.
Yes, I've shown the result of having squared 9.8. When I square 9.8, I get 96.04. When I square meters per second, I get meters squared over second squared. In step 3C, I just multiply by 3 kilograms and my units switch to joules. My final step is to divide by 2. Any questions on how to show a calculation of kinetic energy? There is a 100% chance you will have a question on the test tomorrow asking you to calculate kinetic energy.
Yeah, could you just show the whiteboard again?
Yep, I can.
Thank you.
And I can, did you do a screenshot or something, Natalie?
No, I'm just writing it down.
Okay. If anybody wants me to, I can send them a picture of this, or I have other pictures of math that we practiced before. Just send me a message and I'll get you a picture. All right. That was Dylan, right? How about, let's hear from, I don't think we've had any girls pick yet, have we? Issa, pick a point value in a category.
Energy conversion, 400, please.
For how much?
400.
That one? Okay, so you have to imagine that this is a basketball. It's a blue basketball. Where does the basketball have the greatest kinetic energy? Issa, what do you think? Is it at 1, 2, 3, or 4?
4, maybe?
Well, 4, we're having to fight back against gravity.
Oh, so yeah, 1.
I would argue
Right.
1 or 2. Now, 2, if we could snap a shot of the basketball just before it hits the ground, that would be probably where it has the greatest. I would say in this picture, it's probably 1. You could maybe argue 2. It's showing
Okay.
the basketball kind of flattens, compresses. Does anybody out there know what EP stand for?
Elastic potential energy.
Yeah, so there's various forms of potential energy. The basketball has some elasticity to it, so we say it has elastic potential energy here, which sends it back upwards. So 1 or 2, I think, could work. Ava, pick a point value in a category.
Can we do heat 500? I mean 400?
Yes. A material that reduces or prevents the transfer of energy is a blank, while a material through which energy can be transferred as heat is a blank. Ava?
Is it insulator then conductor?
It is. So we have good definitions of what it means, again, to be an insulator and what it means to be a conductor. I threw the word thermal in front. That's not an absolute necessity. Joe.
Vocabulary 100.
Attaboy. What do we say is the ability to do work, Joe? What's the definition? Or what's
Energy?
Yeah.
Wait.
Energy.
Oh, nice.
Ability to do work. How about Savannah?
Heat 300.
Ooh, a daily double. How many points do you have, Savannah? 8,000. All right. Here's our daily double question. Convert 48 Fahrenheit to a temperature in degrees Celsius. When we took temperature notes, I gave you 2 conversions. I'll just inform you that there won't be any conversions of Fahrenheit to Celsius or Celsius to Fahrenheit on tomorrow's test, but if you have those in your notes, I want you to give it a try anyhow. When you have an answer, you can type it in the chat. Oops. Too high, George. Good job, Aiden. Leighton got it. Oops. I'm all over the place here. Yeah, so we're going to come up with a measurement of roughly 9 degrees Celsius. 9 degrees Celsius. Ben, pick a point value in a category.
Kinetic energy 400.
All right. When a ball rolls down a ramp, it gets its kinetic energy from GPE. This is very much a test question tomorrow. Tell me why all of the GPE doesn't turn into kinetic energy. So as you consider this question, I want you to remember way back to the classroom days, there was a swinging ball demo. And when I let go of the ball, the GPE turned into kinetic energy, and it never made it back to whoever was standing next to the ball. And if we think back to the beginning of distance learning, there was a lab called, oh man, I can't remember what it was called. There was a steel marble that I rolled down a ramp. I can't remember the name. Finding Energy. It was called Finding Energy, and we calculated properly. We always saw that GPE was larger than KE. So the question is why? Give me a little bit more, Court. Same with Preston. What is it lost to? So we want to name the force that
Friction.
robs some of the energy. Be prepared to explain. Good. Be prepared to explain that some energy is lost to friction. Anytime a ball swings through the air like I demonstrated in class, or when a marble rolls down a ramp, or when you dropped an egg drop device from the top of your stairwell or whatever, not all of this gets turned into this, and it's because of this. Not all GPE is converted into KE because of friction. Can't remember who it was. Might have been Dylan. When Dylan made his egg drop calculations, he noticed that GPE was really big and kinetic energy was really small. And he thought he made an error in his math. And then I asked him, did you design a parachute? And he said yes. And that explains why there's such a big difference. A parachute works on the premise of friction, air resistance. Does anybody have questions about this idea here of gravitational potential energy and kinetic energy? Natalie? All right. Oh, goodness. How about Cole? Pick a point value in category, Cole.
Kinetic energy for 200.
Oh my goodness, it's another daily double. I want you to solve the kinetic energy of a 0.161 kilogram object traveling at 0.55 meters per second. This would be a great time to practice steps 3A, 3B, and 3C on paper. Remember when we multiply, or I'm sorry, when we square velocity, we're not going to multiply 0.55 times 2. We're going to multiply 0.55 times 0.55. That's small. If you're coming up with an answer, you can type it in the chat. Oh. Good job, guys and girls. How we doing, Cole?
I got. Where is it? I got 0.0024 joules.
Nice. Good job. Okay, I'm happy to take any questions on how we came up with that answer, but if you are coming up with that answer and you're following that 3A, 3B, 3C format, that's the best. All right, here's the deal. It is 10 o'clock. If you want to hang out for a little bit longer and do some more review, you're more than welcome. If you have other stuff you need to get to, that's fine too. I'm not going to keep you longer than needed, but I'm happy to stick around if you'd like. So I'll just give you a chance to either hop off and move on to other work or hang out. And in about 30 seconds, whoever's left, we'll just do a few more review problems and then wrap things up.
Bye. Thank you.
Have a good day.
Thank you.
Thank you.
Thank you.
You bet. Oh, they're dropping like flies.
I've got a question.
Yes.
So will you be posting this Jeopardy on Edmodo?
Yeah, I'm going to do that in, well, depending on if anybody sticks around, I'll finish up. But I would say by 10:30, I'll have it on Edmodo.
Okay, thanks.
You bet. Okay, so those of you hanging out, you want to play a little bit more? Take a look at some more questions. Carter, you want to pick one?
Potential energy 400.
All right. Calculate the GPE of a ball that has a weight of 0.161 newtons. Ooh, little curveball. It's 9 centimeters above the ground. Careful with that curveball. Carter's a baseball guy. I got to do these with you. Oh, yeah. Oh, yeah. All right, just as we were before, if you want to type an answer in the chat, go ahead. Mm-hmm. Mm-hmm. Izzy, how did you get that answer?
So I converted centimeters to meters,
Yep.
and it was 0.09, and then I multiplied that by newtons,
Mm-hmm.
and
Yep.
then I got the answer.
So I did a little bit of a different way of rounding. I think, well, tenths, hundredths. We're off by a 10,000th, not a big deal. But just a little quiz to make sure that we know a joule is made up of a newton and a meter, not a centimeter. Tomorrow, there will probably not be any curveballs like that. Keep things pretty straightforward. Izzy, you want to pick a point value and a category?
Sure. Energy conversion 300.
Uh-oh. Hold on. Gotta click on the number. All right. This one, yeah, I don't know if anybody will know this one. What would the energy conversion be that takes place in a nuclear reactor? I don't know if anybody dug into this one at all for their energy conversion writing assignment. If anybody knows, you can either say it or type it. Otherwise, we'll skip past this one pretty quick. We got a response from, oh, got it. Does anybody know? All right, so in a nuclear reactor, nuclear energy that's stored within the nucleus of an atom, is released, and it's released in the form of heat, actually. It generates a lot of heat. So a nuclear reactor changes into thermal energy. It produces heat enough to boil water. We can make steam. Steam can turn a turbine, and then we can generate electricity. So there's multiple steps in that. Izzy, you want to try a different one?
Sure. Potential energy 300.
All right, this one might be a little bit more applicable. This was in the Finding Energy lab as well. Why would a bicyclist have more speed rolling down a tall hill compared to a short hill? Again, if anybody wants to type your answer, you can, or we can have somebody say the answer. Good, Preston. So the big thing with this one, this is, I think, conclusion question number 3 on finding energy, which is a long time ago. More GPE is going to lead to more kinetic energy. And since velocity or speed is a part of kinetic energy, we can make that connection. I'm just going to keep going until we're either out of questions or out of participants. So feel free to hang out or head out, up to you. Jonah, do you want to pick a point value in a category? Are you still with us? Maybe not. How about Isa? Pick one.
Energy conversion 200. Please.
All right, this is something applicable. We talked about this. Oh man, what lab was that? Oh, a little bit with the flaming peanut. What kind of energy conversion happens through photosynthesis? What to what? I think I referenced it in the heading of the Flaming Peanut Lab.
Is it light to chemical?
Yeah. Yep. Excellent. Couple more. Preston?
Kinetic energy 300.
Do you know what a pendulum is, Preston?
It's like a, yes.
Yes. When would it have the most kinetic energy?
When it's swinging, wouldn't it, as it's going down, would it have the most kinetic energy?
Yeah, we would probably say right at the bottom of its swing. Because then as it starts to approach back up to the top of its swing, it's got to fight gravity. So at the very bottom, it's kind of like the question that Isa had before with basketball. It's like right at the bottom. Don't know if Jonah's there, so we'll go back up to Carter.
Vocab 300.
The energy of an object due to its motion. And we'll zip through these, so if you have an answer right off the top of your head, you can just say it out loud.
Kinetic energy?
Right. Energy of motion is called kinetic energy. We'll go back to Izzy.
Vocab 200.
Oh, good question.
Is it friction?
Yes, definitely no friction for tomorrow's test. Just the idea that it's present, and it usually is something that we consider a wasteful energy. I remember one of the do-nows that I always used to ask was this idea of like if you're riding in a car and you slam on the brakes and you come to a screeching halt, that noise that's produced, is that a useful form of energy or a wasteful form of energy? Anybody have a thought on that? It's kind of an unrelated, well, it's related, but it's not a Jeopardy question. You know what I'm talking about?
Could you repeat the question?
Have you ever like seen or been in or heard a car come to a screeching halt because it slammed on its brakes?
Oh, mm-hmm.
So the question is that sound, is that screeching sound a useful sound or a wasteful sound?
Is it wasteful because the car is losing a lot of kinetic energy?
Yeah, the bigger idea is that that sound isn't really purposeful. A lot of people like to argue, well, it warns people that something bad might happen. But that's not really its intended purpose. I guess the whole point of me saying that is it kind of relates back to this idea here that it's a wasteful form of energy. Oftentimes, friction is seen as a wasteful form of energy. I don't even know where we left off. That was Izzy, Isa, Preston. Maybe Preston's turn.
Potential energy 200.
Go ahead, Preston.
The clock in your science room?
Yep. Just anything that's suspended above the ground. Carter.
Heat 200.
This was in our temperature notes. I used it to explain how a thermometer works, like the thermometers we have in the classroom, not a digital one.
Is it thermal expansion?
Exactly. Yep. Probably not something super critical to know for the test. Isa,
Potential energy 100.
how about if I throw the word gravitational in front of this?
Height above the ground.
Yeah, we would just say its position or its height above the ground. Potential energy, especially gravitational potential energy, is because of height, position, so on and so forth. That's why we have an element of distance involved when we calculate it. Izzy,
Kinetic energy 100.
go.
Like the birds in your classroom,
Well, what are the birds doing?
they're like suspended.
So then we would have to say that they would have gravitational potential energy. But what does an
Is it-
object have to have if it's got kinetic energy? What does it have to
Does
be
it have
doing?
to be like on the ground or like rolling?
Well, one of the things that you just said is accurate. I don't really care where it is. What does it have to be doing?
Rolling?
Moving.
Moving?
Yep. Something with kinetic energy has to be in motion. Oh no, what did I do? Okay. Carter,
Energy conversion 100.
Carter,
It goes from gravitational potential energy to kinetic energy.
and then back and forth and back and forth. Yep. Preston,
Energy conversion 500.
that's a tough one. Could you just give me one or two?
Kinetic energy.
Well, it's got to be a conversion though.
Oh.
So from something to something else, from one energy type to another. Like, how does the bike move in the first place?
Doesn't say.
Huh?
Doesn't say. It just says when you pedal a bike.
Right. So what I'm asking is what energy conversion allows for a bicycle to move in the first place?
Gravitational potential energy.
Well, if I roll a bike by itself down a hill, or if I just coast on a bike down a hill, then I would be changing gravitational potential energy into.
Kinetic energy.
So there's the energy conversion, one thing to another, GPE to KE. But now let's picture it like we are on level ground. What energy conversion would take place to allow us to pedal a bicycle? Anybody else can chime in too if you've got an idea. Like, what's the energy conversion that takes place to allow any movement that we make with our bodies to occur?
Kinetic energy.
Well, that would be the second part of it. From what?
Is it like chemical energy, like mechanical energy?
I would stick with the chemical part. Chemical energy in your body. So the food that we eat is stored in protein and fats and carbohydrates. Those are chemical forms of energy that we store up from the food that we eat, and those are broken and released, and we get kinetic energy out of that. Now, there's a bunch of steps in between, really complicated steps that allow us to have the ability to move. But the simple idea is that stored chemical energy can be turned into kinetic energy. And then it's just a bunch of kinetic to kinetic in terms of pedals and chains and wheels and all that stuff. All right, last one here, and then we'll take a look at Final Jeopardy and wrap up. Ooh. Who's got that one?
Temperature.
Yeah, average kinetic energy. Good. All right, so this comes from Grandpa Crockett's Trade Secret Popcorn. What's happening at 1? What's happening in 2 and 3? I'll give you a minute to think about it. And then what do we think about 1? Issa, what's going on at 1?
Conduction.
Yep. Carter, what's going on at 2?
Convection.
Yep. And then 3 is radiation. So that's it. Thanks for hanging out. Does anybody have any last minute questions? You're free.
Thank you, Mr. Crockett.
Yeah.
Thank you.
Thank you.